I welcome you in this video. In this video, we are going to solve the problem from GATE 2017 examination. This problem is based on LPP solution by graphical method. Now, this is the problem statement. You go through this problem statement. Now, I will explain this problem statement. Two models of P and Q of a product earn profit of rupees 180 per piece. So that means if we sell 1 unit of P, we get the profit of rupees 100. If we sell 1 unit of Q, we get a profit of rupees 80. While the production time for P and Q is 5 hours and 3 hours respectively. That means for per unit of P, the production time is 5 hours, and for 1 unit of Q, the production time is 3 hours, and the total production time available is 150 hours. For a batch size of 40, so batch size is 40, that means the addition of total units of P and total units of Q is equal to 40. Then to maximize the profit, the number of units of P to be produced is. So we have to determine the units of P to be produced so that the profit is maximum. So let us assume the X1 and X2, the number of units of P and Q to be produced respectively. So X1 is the number of units of P to be produced and X2 is the number of units of Q to be produced. So from this variable we can write our objective function. So objective function is expressing the profit function and it is denoted by Z, and we have to maximize it, so we can write it as a maximum Z is equal to profit per unit of P is 100 and profit per unit of Q is 80, so we can write 100 is per unit profit into number of units of P is X1 plus profit per unit of Q is rupees 80 and total units of Q are X2. So this is the objective function. Now let us write the constraints. Now production time for 1 unit of P is 5 hours. So for 1 unit production time is 1 hour, 5 hours, and units of P are X1 plus production time for 1 unit of Q is 3 hours and total units of Q are X2. So this is the total production time for P and Q, all the units of P and all the units of Q, and the total production time available is 150 hours, so we have to write less than equal to 150. So this is the first constraint of this problem. Now second is batch size is given, it is 40. So we have number of units of P and number of units of Q. So that means X1 plus X2 is less than equal to 40. So this is the second constraint given in this problem statement. And we have to find out the units of P, that is X1, so that the profit is maximum. So let us express this constraint number 1 and constraint number 2 in the form of line by graphical method. To express these two equations in the form of lines in graphical method, we have to find out the coordinates of lines. So for first equation, when the x1 is equal to 0, x2 is equal to 50. When x2 is equal to 0, x1 is equal to 30. Similarly, for second equation, when x1 is equal to 0, x2 is equal to 40. And when x2 is equal to 0, x1 is equal to 40. So these are the coordinates of line number 1 and these are the coordinates for line number 2. And now with these coordinates we have to draw a line on graph. Now let us draw these coordinates of line number 1. So when x1 is equal to 0, x2 is equal to 50. So that means on x-axis we have values of x1, on y-axis we have values of x2. So when x1 is equal to 0, x2 is 50. So this is the first point. When x2 is equal to 0, x1 is equal to 30. When x2 is equal to 0, x1 is equal to 30. So this is the second point. Now let us connect these 2 points. Now this line represents the equation 5x1 plus 3x2 is equal to 150. Now let us draw the second line with these coordinates. So when x1 is equal to 0, when x1 is equal to 0, x2 is equal to 40, and when x2 is equal to 0, x1 is equal to 40. So with these coordinates, let us draw this line. Now with this line, we have to identify, or we have to draw the feasible region. We have to locate the feasible region, and this both the equations, for this both the equation we have inequality of less than equal to. So for both the equation we have less than equal to inequality. So we have to consider the region below this both the lines. So if you observe the common region, which is this region, which is common region for both the lines, that means we have to consider the region below this second line, and we have to consider the region below this first line, and this is the common region, and this is the feasible region, which gives us feasible solution. Now let us consider the points of this feasible region. So this is point A, this is point B, this is point C, and this is point D. Now let us consider the coordinates of point A, B, C, D. So coordinates of point A is 0, 0. Coordinates of B, it is 30, 0. Coordinates of C, if you consider, it is 15, x is 15, x1 is 15, and this x2 is 25, and D, it is 0, 40. Now let us find the values of this objective function z for these coordinates. That is, simply we have to put value of x1 0, value of x2 0 for this. So for when a is equal to 0, 0, z is equal to 0. When b is equal to 30, 0, that means x1 is equal to 30 and x2 is equal to 0. So we will get here 3000. So likewise we have to calculate the objective function for all these four coordinates. When we put x1 is equal to 15 and x2 is equal to 25 in this objective function, we will get the value of this objective function as 3500. And similarly, when we put x1 is equal to 0 and x2 is equal to 40, we get the answer of this objective function as 3200. So these are the values of objective function for all the points of this feasible region, and we have to identify the maximum value of this function, and the maximum value out of this 4 value is 3500, and it is at the coordinates, that is 15, 25. So here this 15 is nothing but the x1 is equal to 15 and x2 is equal to 25, and we have to find out the units of p to be produced. That means we have to write this answer as this is x1 is nothing but the units of p. So our answer is units of p to be produced is 15, because x1 we have assumed as number of units of p to be produced. Okay, if in this problem the number of units of q to be produced will be asked, okay, then you can write the answer as number of units of q to be produced is 25, okay, and number of units of p to be produced is 15. So our answer is 15 in this case. So answer is number of units of p to be produced is 15, and this is the answer.